All right, welcome to our Algebraic Operations chapter. This is both a summary as well as an introduction to a couple concepts. And this will cover everything that is in the summative for this particular chapter. And we will be covering in this chapter algebraic notation, the language of mathematics, collecting like terms, generalizing arithmetic, algebraic substitution, algebraic products, and algebraic fractions. We have already covered half of this, okay? But I will still go over the contents of A through D to review it, despite the fact that we've already covered this, and recently, last week, just had a test on that. And then I will also be now introducing these concepts here, which may not be an introduction to all of you, but is part of our summative, which includes this entire chapter. Okay, let's start with algebraic notation. With algebraic notation, you will recall that we leave out the x sign, the multiplication sign between multiple quantities, and we write numbers first. And where the products contain two or more letters, we write them in alphabetical order. This is review. So we see, as an example, that 3b is used instead of 3 times b. Okay? And it's used instead of b3. So remember that. And 3bc is used instead of 3cb. I'll give you an example, and I'll pause it for you to try. Okay? Here we go. All right, we have 2 times D times A. Pause and solve this or simplify this. Okay, you should have written 2AD in this particular order with the number first and A before D. Second element is to write sums as products. Sums are when you add something together, like the sum of 4 plus 5 would be 9. That's the sum of 4 plus 5. Here, the sum of 3 plus 3 plus 3 plus 3, the sum equals 4 times 3. Okay? The sum of b plus b plus b plus b is the same as 4 times b, which equals 4b. The other part of product notation is simplifying. And so let's have a look at this. We have s minus t plus t. I want you to pause and simplify j, k, and l. All right, these are the solutions that you should have had if you had done this correctly. S minus 2t. Okay. 5, we take the constants, the 4 and the 1. 4 plus 1 is 5, and we take the r's, and that will become 3r, because there are 3 r's. That'll be 5 plus 3r. We have 2 plus a plus a plus b plus b. This will be 2 plus 2a. Our 2a's are here. And our 2b's are right here. All right, so this is, again, we are writing sums as products. Okay, we are writing like a plus a plus a is a sum, and because we're adding that up, it will be, the product will be 3a. Okay, this is now different from index notation. Index notation is that little letter, like the little exponent, that little letter that goes above a number or a letter. And it implies that there are 4 of those and that we're multiplying them together. Our first example is 3 times 3 times 3 times 3. With index notation, it is 3 to the power of 4. B times B times B times B. Index notation is B to the power of 4. Okay, and here is an example, And again, this is review for you. So let me just give you an example. This would have at number 4 here, and I want you to pause the video and do numbers A, B, E, and F. What you're doing here is you are expanding. That's the verb. You are expanding. Okay, these should have been your answers. A to the power of 4 is A times A times A times A. F to the power of 2 is F times F. 5x to the power 5x squared. Y is 5 times x times y. That's number E. And F. 7 f to the power 2 g3 would be 7 times f times g times g times g. There are 2 f's, there are 3 g's. There are 2 f's and 3 g's. Okay, I want you to go ahead and do M and O. So pause the video and let's try M and O. Before I forget, very important. You see, I've forgot to tell you, what are we doing? We are writing in the simplest form. We are not expanding. We are simplifying this. So we are taking these expressions and we're making them like these expressions over here. Okay? And these are expressions. They are not equations because there's no equal sign. So go ahead and let's turn M and O and simplify them as much as possible. Okay, so this should be your solution. Now this does seem a little bit complicated. M is 2h to the power of 2 minus jh. O is a to the power of 2 plus 2b to the power of 3 minus ab to the power of 2. All right? Just to break this down, I'm trying to figure out why it is this way. We can give a number for a. So let's just say that a equals 3. All right, if a is 3, and we have this expression, a times a, that would be 3 times 3 plus 2 times, and let's say b is 4 times 4 times 4 times 4 minus 3 times 4 times 4. Okay, now let's break this down and simplify this. 3 times 3 would be the same as 3 squared plus 2 times 4 times 4 times 4. So that would, in a sense, be 2 times 4 to the power of 3, right? Minus 3 times 4 times 4, which would be, in a way, 3 4 squared. Now, this should make sense to you, and if you did it on a calculator, you realize that's the way it is. And if it looks just like it is with the letters. So if I just take the letters now, we have a squared plus 2 times b to the power of 3. We have our minus ab squared. And this reads exactly like the solution or the expression that I did when I made A3 and B4. I hope that makes sense to you. I will just briefly go over this. These words, you need to memorize them. You need to know what they are. Okay? Again, variable is an unknown value. It is any letter that we don't know the value of. Okay, we have here 3 examples, P, L, and W. An expression is an algebraic form consisting of numbers and operating signs. So we have an example of expression here. There's no equal sign. An equation has an equal sign. Okay, so it contains, and you can see it contains an equal sign. These are equations. Terms, you guys keep getting this incorrect. Terms are algebraic forms which are separated by a plus or minus, like a plus or minus sign. The signs are included. So here we have an example. We have 1 term, we have 2, 3, and 4. We have 4 terms. All right. Like terms are terms that have exactly the same variable form. Like we have x and we have x. xy is not the same as x. Y is not the same as xy. Constant term is a term that does not contain a letter, a variable. So in this equation right here, the only constant term we have is 7 because there's no letter with it. Last but not least, the coefficient is the number factor of an algebraic term. So for example, 4 is the coefficient of x, 2 is the coefficient of xy, negative 1 is the coefficient of y3. Now you're like, wait, there's no negative 1 there. Negative y3 is the same as negative 1 y3. Because there's, if you think about it, there is one y here, right? Well, there's one letter. There's 3 of them, but there's one letter. It makes it a little bit strange. But if you think about it, there's one y in, as we're looking at it right now. Therefore, there is like a hidden negative 1. Okay? That is the coefficient of y squared. The coefficient of x, if I just wrote x, the coefficient of x would be 1. Okay? If I made x negative, the coefficient of negative x would be negative 1. There's just one negative x, so it's negative 1. You're using hidden. All right, so let's have a look at this. I want you to pause the video, and I want you to write down the terms, the number of terms. Okay, hopefully you wrote 4. X squared plus 2x minus 5x minus 10. Now, what is the coefficient of x? Well, if we look, there is a plus 2, and there's also a negative 5. So the coefficient of x in this case would be 2 and negative 5. All right. The constant here is negative 10. The constant is negative 10. All right, so let's go to collecting like terms. Again, this is we're in still review here. We've seen that like terms are algebraic terms, and they contain the same variable, the same letter, and the same indices, okay? So, for example, 2x and 3x both have the same variable. So we can combine those. That would be 5x. All right? 4x and plus 2x squared, we cannot combine those. They have the same variable, but you see this little index here? It's different. There's no index here. So we cannot add those together. Let me prove it to you. If x, let's say x equals 2, okay? So if x equals 2, 4x is the same as 8, and 2x squared, oh, that would be 8 too. This is a bad example. Well, we can't add those together. I think the best thing to remember is the algebra tiles that we played around with. We know that the x, this is the x, this is the x squared. They look the same, they look different, so we can't add them together, all right? Because we don't know what is the value of that variable. Okay, so let's go to these problems here. I want you to pause the video, and I want you to try and solve number 1, 2, and 3 by not solving, but combining the like terms, collecting the like terms. Go. Okay, this is what you should have had. Number 1 should be 12w. You have 3 plus 4 plus 5. 4, 5, 6, 7, 8, 9, 10, 11, 12. We have 12w. Number 2 should be 0 because we have 2m's and 3m's, and then we have a minus 5m. So that's 2 plus 3 minus 5 is 0. 3 should be 4s. We have an s, and we have a positive 3s. So s, 1s plus 3s's is 4s. Then we cannot combine this because that's an s squared. Because of the index, that little 2, we cannot combine 4s squared with 3s or s. So our combined like term expression will be 4s plus 4s squared. Go ahead and do the last two. Pause and try and solve the last two. Okay, you should have had negative 3x squared, negative 7m minus 2m. Negative 3x squared, y, we have negative 3x cubed plus 3x cubed cancels it out. Okay, that leaves us with negative 2x squared and a negative x squared. And we can combine those and we get negative 3x squared. On the bottom, we have negative 6m, and we also have a negative mn. They're both negative, so we can combine those to get a negative 7m. We have plus 3m and minus 5m. We combine those. 3 minus 5 is negative 2. Negative 2m. All right, now we're coming to a cool thing. We have algebraic substitution. All right, I just added a picture of a crazy substitute teacher. Wouldn't you like to have him as your substitute if I'm out sick? So, the key here, the words that you need to be aware of is to evaluate. Okay, in other words, you're finding what is the value of this expression. And what are we doing? We find the value by substituting particular numerical values for the variables. So in other words, we take a letter and we plug in a number. So here we are substituting 3 for w. Here we are substituting negative 1 for x. Here we're substituting 4 for y. And here we are substituting negative 2 for z. So then it's asking us to evaluate this. All right? So if I was to evaluate 2x plus y, now I know what x is and I know what y is. So this is going to be 2. And we know that when a number and a letter are together, it means they're multiplying. That's going to be 2 times x. What is x? Negative 1. And then we're adding y, which is 4. 2 times negative 1 is negative 2. Negative 2 plus 4 equals 2. Okay? So we have evaluated 2x plus y. I want you to pause the video and do the other two. 5x plus 2y and y squared minus wz. All right, you should have had 3 for 5x plus 2y, and you should have had 22 for xy minus wz. Okay, if you're wondering why, we know x is negative 1. 5 times negative 1 is negative 5. Negative 5 plus 8 would be 3. Now the second one is a little maybe complicated for you. Y squared, y is 4, well, y squared, so that would be 16, correct? I'm going to write it in red here. Now we have 16 minus 3. We have minus w, w is 3, and z is negative 2. So that's going to be minus 3 times negative 2. And you have two negatives, and you multiply them together, you get a positive. So it's going to become a positive 6. That leads us to 22. All right? Again, negative 3 times negative 2 is 6. And this little thing, those two negatives will and do tend to throw all of you off. So that's what you got to be very careful of. Now, we have a couple other ones that are a little more complicated. They look complicated, they're in fractions. I want you to pause the video, and I want you to solve those right now. Okay, for this first one here, 2j times L divided by n, your answer should have been 3. We have j is 5, so that's 2j is 2 times 5, plus L, which is 2. 2 times 5 plus 2 is 12 divided by 4, and m, which is 4, so that's 12 divided by 4 is 3. L squared, this one right here, L squared, L is 2, so that's 2 squared times m, which is 4, and j squared, which is 5 squared minus 21, so you can have 16 divided by 4 equals 4. That should be answered for number 2. Again, all you're doing is substituting the number for the variable. Okay? I like to use another word, or better, more accurately, a phrase, which is plug and chug. You plug the number in and you chug. You plug the number in and you go through the expression. All right, now we are finally coming to the end. We have 2 more slides in this long tutorial. I understand it's long, but it is the last tutorial of this particular subject or chapter in algebra. So when we have algebraic products, which means when we are multiplying terms of algebra, the first thing we do is we calculate the coefficient of the final product by multiplying all the numbers. Again, the coefficient. Here we have the 2x times 3x. The coefficient of these numbers is the number in front of the variable, which you should remember because you've memorized this from our language and math. From this particular slide here, the coefficient right here is the number factor of an algebraic term. So you've memorized that, you know that, and you know that, well, here the coefficient, what do? We calculate the coefficient by multiplying the numbers, so we go 2 times 3, which is 6. And then we simplify the unknowns using index notation when appropriate. Now, we know index notation, okay, through this slide here, index notation. All right, 3 times 3 times 3 times 3 is 3 to the power of 4. B times B times B times B is B to the power of 4. Okay, so we have our index notation, so we now know that, well, there's x times x. X times x is x squared. So here we got it. Okay, 2x times 3x is 6x cubed. All right, so I want you, let's work through this first one, and then you can do the other 2 together by yourself. So 4x times 7x squared. Very first thing we do, calculate the coefficient of the final product. What's the coefficient? Well, 4 and 7. 4 times 7 is 28. The second thing we do, we simplify the unknowns using index notation. Okay? We have an unknown here, x, and we have an unknown here, x to the power of 2. How many x's are there? If we break this down, we know that this whole thing, we could write it out like this. Right? So how many x's are there? There's 1, 2, 3. So this would be 28x to the power of 3. Okay? So we have just simplified this algebraic product. I want you to pause the video and do the last 2. All right, let's see if you got this. 2g squared times 5g squared would, if we expanded it, we would have this right here. Our coefficients, 2 and 5. Our variables, g, 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 g. Second one, 4x times 3x squared times 2x. We have, if we took this and we expanded it, we would have it right here. Our coefficients are 4 and 3 and 2. That's 4 times 3 is 12, 12 times 2, 24. Our variables, x, x, and x, and x. There are 1, 2, 3, 4. That would be x to the power of 4. Okay? Okay, here we are into algebraic fractions. And they are fractions which contain one variable. Okay, look at this thing. It looks really ugly. What is it? Well, let's expand it. 15, P3. There's 3 P's and a Q over a 3 times a P. And now we can simply cancel out our P's. What do we have in common? Well, we have our 1 P here. We have 1 P there, correct? So that would leave us with, on the top, 2 P's and a Q. Now we can take our constants, which is 15 and 3, and we can simplify those. 15 divided by 3 is 5, right? 15 divided by 3 is 5, so we have our answer. All right, remember the canceling part that I did right here. Just think, if I had 4 times 2 divided by 2, it would be what 4 times 2 is 8, and 8 divided by 2 equals 4. It would almost be as if, well, 4 times 2 divided by 2, we don't even need this. We get the same answer that we would get if we went through all of that. So when you divide something by the same thing, it's basically canceling itself out. And that's what happens here. Okay, let's look at the second problem. And we have this problem right here. Why don't you give yourself a minute and see if you can do it on your own. Okay, if I expanded that, it would look like this. I just like to take my red pen. Let's just cross out the like variables. We have 2 x's on top. We have 1 x down here. We know that cancels each other. We have 3 y's on top, a y down here. We can cancel out one of those. And we have 1 z on top and another z down here. We can cancel that out. What does that leave us with? It leaves us only with, on the top, an x and 2 y's over a z. Pretty simple? Yes. All right, here we are, last page. Multiplying and dividing algebraic fractions. I know you love to multiply and divide fractions. Just remember, when we multiply fractions, we multiply the numerators together and we multiply the denominators together. Okay? So, for example, in this example here, A times B times CB, we just multiply the numerators and then we multiply the denominators. And our answer will be AC over BD. That's it. Let's try this together. Okay, what is this? Well, it's going to be, we're multiplying, so we just multiply those. Okay, and we bring them together. Okay, simple as that. Let's look at this one now, and we're getting back to, it's getting interesting. So again, I like to draw this big long line here, and I can go ahead and erase that right now. You can always go backwards if you want. So I like to draw this big line because basically we're just multiplying straight across. So we have P times 2 over 6 times P. What do you recognize? Maybe from the last page. What do you do when you're dividing fractions that have variables? You cross out the variables if they're the same variable on the top and the bottom of the fraction. We have a P here and we have a P here. That leaves us with 2P over 6. And now we can simplify the 2 and the 6, and we can get 1 over 3, 1P over 3. All right? The 2 and the 6 can be simplified. Let's now, if you remember, you might have remembered I stood on my head once. I stood on my head. Do you remember that in class? And that's what we do. Why did I do that? I did that to show that we do not divide fractions. We multiply fractions, but we flip them upside down. Okay? And we multiply straight across. And that's what we do with this. They have a good example. A over B times C over D is the same as A over B times D over C. So they take the dividing sign, which is right here, they flip it to a multiplying sign, and then they flip the second fraction, taking the denominator and putting it on top. And that's exactly what happens here to all of these. Okay, this would be A over 7. We're not going to divide fractions, so we multiply the reciprocal, which would be 4 over B, which would be 4A over 7B. And that's basically what you do with all of these. Pause and try these last 2 problems. Okay, you should have had this. The top one, we're multiplying. So we don't need to flip the second fraction, so we just multiply straight across. X times 3 times y over 6 times x. Oh, we have 2 x's. And so that's going to end the 3 and the 6. So the 3 can become a 1. The 6 can become a 2. So we're going to have, basically, I've run out of room, 1/2 xy. Okay? On the bottom one, we are dividing. So you got to flip this and multiply. which brings the a square on top and 9b on the bottom. So you're going to have a fraction where you're going 12 times a times a times a, and b times b times a times a. Okay, we can get rid of our like terms, which is a. That leaves us with 12a over b squared. Okay, that's it for this big, massive tutorial. This is a review tutorial for this entire unit. All right, and my suggestion is that over the weekend you watch this and take notes on it and study up for everything that is in this unit.